So Chapter 9, Section 1, we're going to do some things in here that are practice. I'm going to show you how to have StatCrunch do them for you. The finding the z alpha over 2, this critical value, is something that we're not going to have to do a lot when we're doing confidence intervals, but I want to show you how to find it. So I'm going to go to StatCrunch, and what we're going to do is, if I want to be 85% confidence, that means I want to have the middle percentage to be 85. So let's show you what I mean here. Let's look at a normal distribution because I'm dealing with z. And if I'm looking at between, I want the middle part to be 85%. So let's see if I could do that. So if I have the middle part 85%, that means my cutoff values, or these critical values, are going to be negative 1.44 and positive 1.44. So that means I have 85% within this region, which means I have 7.5 over here and 7.5 over here to make the other 15%. So the cutoff value, we're just going to use the positive, and we'll just say it's 1.44. When we use the formulas for confidence intervals, it says plus or minus your z alpha over 2, so that's accounting for the negative 1.44 and the positive 1.44. Let's go ahead and make a confidence interval. These are pretty easy to make with StatCrunch. If we're given some information, right? So I know that my number of successes is 125, the number that I sampled was 250, and I want to be 95% confident. So we're going to kind of talk about what this interval is here. The book gives the formula for a confidence interval to be p hat plus or minus a margin of error. Well, this is going to find us what that lower bound and upper bound is. So let's go to our StatCrunch. We know x is 125, n is 250, and it's a 95% confidence. So since I'm dealing with population proportion, what we're going to do is we're going to go to proportion stats, one sample with the summary of the data. So everything in this section should be dealing with proportions. So we had 125 successes out of 250, and we wanted to be 95% confident. We're going to keep it on this standard walled. That's the one. There's different algorithms to create a confidence interval. We're going to use this one. This is the one that aligns with my stat lab. So once I do this, bam, I get a lower limit and an upper limit. So it does all the calculations that we need. We know that the sample proportion is 0.5, and that just comes from 125 divided by 250. That's what our p hat is our successes over total sampled. So that's 0.5. And then the formula is p hat plus or minus a margin of error. So this gives that plus or minus. So I said 0.5 plus a number, and 0.5 minus a number gives me the lower limit. In this case, it looks to be about 0.062 would have been our margin of error, just by subtracting my upper limit and my p hat. So let's type these in, make sure they match up. My lower limit to 3 decimal places is 0.438, and my upper is 0.562. And we've made a confidence interval. Also in this section, we're going to be doing sample sizes. So let's look at number 12. So they have some formulas in the book that you can use if you like. There's a formula if you have a previous estimate, and there's one if you do not have a previous estimate. So let's talk about that. Before I talk about that, actually, let's do something else. So we did a sample and we got 50%. So our lower limit and upper limit, what it means What it stands for is that I am 95% confident that I feel like the true population proportion is going to be between these values. So our sample was 0.5. Again, every time we do a sample, it could be different. But we are 95% confident that our true population proportion is in between roughly 44% and 56%. We got 50% in our sample, but we think the true population proportion is in between 44% and 56%. All right, so back to this number 12. So if I want to determine a sample size, I know that I want to be 99% confident, and I have a margin of error. I want to be within 0.02, so that's my margin of error. And I have a previous estimate of 0.32. So if I go to my proportion stats, one sample, I do power and sample size. Again, we're going to do confidence interval. We're not dealing with power. That's something you might do in a different class. We were going to be 99% confident. Our target proportion, our previous estimate, was the 0.32. Now the width is the thing a lot of people get wrong. So if we wanted to be a margin of error of 0.02, that means we went 0.02 to the right and 0.02 to the left. So we added 0.02 to our p-hat and we subtracted. So our width is actually 0.04. So the width is double your margin of error. And then now, sample size, 3610. On the next one, if we don't have a prior estimate, what we're going to use is 50%. That's our best guess. If I said, hey, what percentage of people like bananas? If we don't have any other sample to go by, our best guess is 50%. So we're going to do the same thing, except put in 50% for that target proportion. And let's go ahead and change this back to 0.04. And we get 4147. When you use 50%, it's also going to give us your largest sample size that you would need. If we have a prior estimate, we get smaller numbers of people we have to sample to be 99% confident.